when we've looked at graphs. We've looked at graphs of functions that have very nice coefficients, which have given us very nice coordinates of points on the graph. In real life, we will often encounter functions that have really unpleasant coefficients. And in order to analyze their graphs, we will just have a computer draw the picture for us, or we'll just make a very rough sketch of what the graph looks like approximately. But we're still going to need to know the coordinates of those key points in order to consider questions about the function. And for that, we're going to use our various formulas for working with quadratics. So in this example, we have a function with pretty unpleasant coefficients. And we have a graph that's drawn on unlabeled axes, right? Notice there are no numbers on the x and y axis in this graph. And what we'd like to do is to figure out what the coordinates of these points, A, B, C, and D, are. So in order to do that, we're going to go through and we'll see what each point represents and then how we figure out its coordinates. And we have an instruction here that tells us to round to the nearest integer. So it seems likely that we're going to get some unpleasant numbers in this process. So I'm just going to go through this left to right, except for one weird thing that we're going to see as we go. So point A here, that's where the graph crosses the y-axis. That's our y-intercept. The y-intercept is the easiest thing to find because we have just, this is where x equals 0. So we'll take p of 0 is negative 0.03 times 0 squared plus 13.7 times 0 minus 219 is negative 219. So the coordinates of point A are 0, negative 219. That one's easy. And I'm going to write it down, and I'm also going to label it on the graph. So this is 0, negative 219. Okay, so this graph does not at all have tick marks every 1 unit, right? This is negative 219 on the y-axis. Okay, I'm expecting some big unpleasant numbers, I see. Point B is an x-intercept. And we have another x-intercept. That's point D. These are the points where p of x equals 0. That is negative 0.03 x squared plus 13.7x minus 219 equals 0. That's a quadratic equation. I know how to solve that. I'm going to use the quadratic formula. These are definitely unpleasant numbers. I definitely don't want to try to factor or complete the square for coefficients that look like this. So our x values here are going to be x is negative 13.7 plus or minus the square root 13.7 squared minus 4, 0.03, negative 219, all over 2 times negative 0.03. And I'm actually going to just throw this into the calculator. I'm going to use the calculator's variable storage to actually calculate this. My discriminant is 161.41. And so we get the solutions x equals 16.58, etc., which will round to 17, and x equals 440.07, etc., which will round to 440. So point B has the lower x coordinate. So point B is 17, 0, and point D is 440, 0. So I'll label those. B is 17, 0. D is 440, 0. And that only leaves point C, which point C is at the top of the graph. Point C is the vertex. So to find the coordinates of the vertex, we'll use the vertex formula. So H is, we already wrote down our A, B, and C. H is the opposite of 13.7 over 2 times negative 0.03, which is 228.33, etc., which will round to 228. K is the opposite of 13.7 squared minus 4 times negative 0.03 times negative 219, all over 4 times negative 0.03, which works out to 1345.08, etc., which will round to 1345. So the coordinates of point C are 228, 1345, rounded to the nearest integer. We'll label that. And we've labeled our graph. Now we notice that our x-axis and our y-axis are on slightly different scales. That's fine. That's normal with real-world numbers because often our x values and our y values are on slightly different scales. But this is a really common approach to graphing something with unpleasant numbers. You make a graph of roughly what it looks like, and then you go through and you label the coordinates of the actual points.